Computer-based plant engineering. The first generation of tools that were used in plant engineering industrially were introduced in the years between the 60s and the 80s. The main trend was the digitalization of documents, or in other words, doing whatever you could do on a paper now on a computer. Therefore, in each engineering discipline, computers were used to design spreadsheets and digital drawings. As the number of these drawings and lists grew, it was necessary to store them in a digital file library. Combinations of AutoCAD and Excel are the typical modern examples of this generation. The next generation was introduced around the 90s. In this concept, there are shapes placed on diagrams of different disciplines, and these shapes are related to a set of attributes that hold the data. So, for example, if you click on a representation of a pump in a P&ID, you can see the attributes of that pump. Basically, diagrams are the containers of the data. Instead of file libraries, databases are used to store these intelligent diagrams and their metadata for each of the engineering disciplines. Using databases provided advanced search and report generation possibilities. Parallelization of engineering demanded synchronization of the data in different disciplines, and therefore a synchronization agent, which is typically called a platform, was patched to improve the data communication. So, as a result, we have objects on diagrams, we have databases to store diagrams, and it is a three-tier software architecture. Nonetheless, modern and true parallel plant engineering is beyond documents and diagrams. The latest advancements in technologies used in plant engineering are going in the direction of model-driven engineering. To have a better understanding of this approach, let us make an example of the data model for a water supply system. For this system, we need different equipment, such as a tank, which can be physically located at a tank farm. We need a pump, which can be in the pump station. We need instruments and terminals in the junction box, and a control cabinet, and a control system to control the process. The first model that can be derived from this picture is the equipment model. The second model is the functional model. And the third model is the location model, and there should be associations between these three models. As a result, the plant data model is actually the unification of these three models, combined with graphical representations in 2D or 3D for all plant engineering disciplines. A plant engineering software tool that is designed based on the model-driven engineering concept contains all aspects of the plant data model with the unlimited graphical representation of objects and data on all types of diagrams and reports. This package is then stored as a project in a central database as a single source of truth. This plant data model and documentation are accessible to all engineers, independent of their disciplines, location and language, in real time for true parallel engineering. Engineering Base is a product that is genuinely designed based on this concept to enable parallel plant engineering and is now utilized by plant engineers around the world. Using a single source of truth demands change management technologies and workflows, which you can learn about in the next video.